This video reviews how to apply a whole number data validation restriction to a column of data in an Excel workbook by using the Python library OpenPyXL. Here is my testing document. It has two columns, one titled Food, one titled Amount. Into the Amount column, I will be using Python to add a data validation for whole numbers, effectively making sure that we are capturing whole numbers for the amounts of different foods that we have in our table. Here I'm bringing in the workbook as WB and selecting the worksheet as WS. I will then save the work in the cell below. I will be saving this work in a separate Excel document because I will be iterating over my work and saving as I progress to the final product. I will also be importing the original testing workbook multiple times throughout this demonstration to ensure that I have a fresh workbook on which to conduct my work. To use this form of data validation, I need to import the data validation object from the worksheet.dataValidation module of OpenPyXL. Here you can see how to appropriately import it. I will start with a very simple whole number data validation, one that simply checks if something is a whole number greater than 50. You can see I am accessing the data validation object that I just imported, and I will be calling the variable dv. To that object, I pass a few arguments: type, operator, and formula1. Type indicates which of the available data validations I would like to use. We will be using whole, so I will pass that as a string. The operator is what I will be using to evaluate whether or not the input passes. Operators available to us are things such as equals, greater than, less than, and all of the other ones that you would expect in a normal mathematical comparison operation. Finally, the formula1 argument is what the operator is compared against. I put in 50 because we want to know whether the input is greater than the integer 50. The next three lines are how I add that data validation object to the pertinent cells. You'll be seeing this code several times in this video, so let me explain what's happening. Each worksheet object has an add data validation method, which accepts a data validation object. You can see I am passing our newly created data validation called dv to it. I then have to tell the data validation object which cells on the worksheet it should affect. We want to only fill in the column B, from the second row all the way down to the end of the data. I will use a ranged function to accomplish this, starting with 2 and going all the way to the maximum row plus 1. I use plus 1 because the range function does not include the second number in it, so I must add 1 to ensure I'm capturing the whole column. In the function, I then access the add method on the data validation object and pass it the cell I would like the data validation object to affect. You can see I am passing the loop variables row as the row and b as the column. This way, all of the cells will be affected. Let's execute the cell and save the workbook, then reopen it to check the work. Here is our B column, and let's enter a number. 7. Well, nothing seems to have happened. We have a data validation on the column, but I haven't specified what should happen when an incorrect number is entered. We can verify we have incorrect data by clicking on the Data tab, going to Data Validation, and clicking Circle Invalid Data. And there it is. All cells are invalid because none of them have a number greater than 50. Well, this is fine, but it's not all that helpful. Let's modify our data validation object. I'm going to re-import the original test document so that we start with a fresh, blank workbook and bring in some updated code. So here we see a lot of what looks very familiar. Starting with the bottom, we have the exact same 3 lines of code as the code block did previously. In the data validation object creation, the first 3 arguments are also exactly the same. What I added as arguments are error, error title, and show error message. These 3 lines of code are responsible for informing the user that they have entered incorrect data. The first argument, error, is the body of the text box that pops up when a wrong input is encountered. This time, when I enter the number 7, we should see a message with invalid number, enter something greater than 50. The error title is the title of that text box, so our title should be error with 2 exclamation marks. Finally, show error message is a Boolean that controls if the message is displayed at all, so I will change this to true. Let's execute this, save the document, and see what we were able to accomplish. Let's enter 7, and there you go. Our error box has popped up. There is error with the 2 exclamation points, and our message as we declared it in the object's creation. I'll exit out of this, and you can see my input of 7 is gone. So we are getting closer to a well-defined whole number data validation object. The only thing that I think is missing is some sort of indication that this column is even expecting a whole number to populate it. Let's switch back over to Jupyter Lab, and I'll change that. Once again, I bring in my initial test workbook so that I have a fresh one, and then I'll pull over this last bit of code. And once again, there is only a little bit of updated code in this data validation object creation. It's these 3 lines right here. The arguments prompt, prompt title, and show input message. Similar to the error message, we are able to supply an input message that displays once you hover over the cells where our whole number is expected. These arguments are fairly self-explanatory, but let's go through them one by one. The prompt argument contains the body of the message. Ours will say, enter number above 50. The title of the prompt will be input with 2 dashes on either side of the word. Finally, we access the show input message Boolean and assign it true to make our input message actually display on hover. Let's execute this final block of code, save the workbook, and reopen the document to see if this has worked. And there it is. Not necessarily the prettiest input display, but it works for this simple demonstration. If we try to enter anything below a 50, you can see I still have that error message popping up as well. And once I do put in a number above 50, no error message pops up and the number is contained in the cell. So overall, it's fairly straightforward once you break it down. You just import the data validation object from the worksheet.dataValidation module of OpenPyXL. You then create your data validation object, passing it the arguments necessary for your use case. You add your data validation object to the worksheet with the add data validation method, and then finally apply the data validation object to the appropriate cells. As always, thank you for stopping by and checking out this video. Please leave a comment below letting me know if you liked it and letting me know what other features of OpenPyXL, Python, or Excel you would like to see reviewed in future videos. Please do give it a thumbs up if you liked it, as that does help others find this content. And don't forget to hit subscribe so that you know when the next video comes out.